Let's take a look at the basics of working with Docker. Let's start Docker Desktop. We can check if it's running or not in the bar here by the time. It takes a little while, but eventually it will start. Let's take a look at the settings first. We'll find it right here by the settings cog. Now we are in the General tab. Although they recommend having this one checked, I generally don't recommend it. I have had bad experiences with this. I don't know if it's a bug in Nete or in Docker or where, but last year when I checked this, Nete applications had very long load times. I even wrote a blog post about it. You can find a link to that article in the comment section of this video. I usually uncheck Send Usage Statistics here, and we should have Use Docker Compose version 2 checked already. On the Resources Advanced tab, I definitely recommend putting some reasonable amount because Docker is really a whale and requires quite a lot of resources. I have an 8-core processor, so I've dedicated 2 cores and 4 GB of RAM, 1 GB for swap, and I've even had to increase this one over time. Moving on to the File Sharing subtab. Here I recommend sharing all the drives you have and work with to prevent any future problems. Once you've made your changes, this is where the Apply and Restart button lights up. Click it and Docker will restart. That's all from the basic setup. Now a little bit of theory. What is Docker good for? Docker allows you to create other virtual machines inside your computer with a precise environment inside. That means a specific version of some software that communicates on some specific port and so on. Thanks to Docker, there are no typical problems when each member of the programming team has a different operating system and needs to prepare an environment, for example, PHP in a specific version, a patch with some specific settings, etc. The procedure to prepare this environment will vary from system to system, even version from version, sometimes quite substantially, and preparing such an environment is therefore quite a complex task. Docker makes these problems go away. You can, for example, test your code in PHP of 4 different versions relatively seamlessly. All you have to do is create the right Docker container or containers once, and you don't have to worry about anything else. Docker replaces these problems with other problems that we assume or hope will be smaller and less frequent than the original ones. When working with Docker, you will most often encounter 2 basic terms. The first term is images. These represent some specific system or piece of software, for example Ubuntu, Debian 10 or Apache, in some specific state. You can either create these images from other images, or you can write a detailed recipe from scratch on how to prepare that image, line by line, to install each tool using, for example, apt-get. Or there's a central repository of pre-made images where you can find virtually any software that's even slightly used. These images are then used to create so-called containers, which are specific instances of those images running on your computer. You can start those containers, shut them down, individually or in a group. You can open specific ports to them and communicate with them externally from your computer. If you don't do that, the container is a closed box that you just can't get into from the outside. The most well-known such repository for finished images is the so-called Docker Hub. Here we can find virtually any software that is at least a little bit used. For example, Apache under the name HTTPD, or MySQL, Adminer, PHP, and many others. Let's take a look at PHP to see what it looks like. We can see this is the official image created probably directly by the author of this software. We'll find some documentation on how to run it, how to set it up, and so on. And here in the text tab, we find all the published versions of this image. There's a really large number of them. Thanks to these tags, I can download an image of a particular, for example, very archaic version into my Docker. Alright, 5.3 isn't here anymore, so 5.4 with Apache together, and here I even have a command how to download the image. Let's have a look at a specific example. For the last few years, a popular tool has been RabbitMQ, which is some sort of task queue. We don't need to go into details now. And when my PHP application will use and need RabbitMQ to work properly, I basically have two options. Either I try to install it on Windows from some installation files, for example exe or MSI, or I can just run Rabbit as a service in Docker. Let's have a look at the latter case. I would find the whole procedure I'm going to show here from the documentation that comes with this image. If we look at the tags, one of the tags is 3-management, which means it's the newest of the third version along with the administration. This is the image I'm going to install here. Now I'm gonna need to open a command prompt or a terminal. In Windows, I'll do that with CMD and enter. And I will start typing the command that I would find in the documentation. Docker run -d --name. Now I will name it somehow, for example, my rabbit -p 8080 15672, but with colon. Yeah, 15672. What does it mean? It means that the container won't be completely closed. It will have one open port. From my perspective, meaning from the outside, it will be port 8080. And that's mapped to internal port 15672, which, if you're using Rabbit, you know is some standard port that the administration interface just communicates on. And now the name of that image in the central repository. If we look, it's called RabbitMQ, and if I want a particular tag, I'll separate it with a colon and type in the name of that tag. So RabbitMQ : 3-management. I hit enter, and it pops up this error. This I did on purpose to show you what happens when you forget to start Docker. So now I start it. I have it running again, and I try to run the same command and enter. Now it's telling me it wasn't able to find the image locally, so it's pulling it from the central repository. Most images are made of several different parts, so each one is now downloading. And done. We can take a look at the Docker desktop. We can see that we have one new running container here in the containers. We can look inside by clicking it. And here we can see what's happening on the command line of that container. And we can see server startup completed. Now if I open browser and type localhost colon 8080, which is the exact port I mapped here, I could map it to any other port. Now I press enter, and here's the Rabbit administration interface. If we go back to RabbitMQ documentation on Docker Hub, and here we have the login and password information here somewhere, and it's guest. We can type it here, and voila, I have a working Rabbit installed on my machine on one-liner terminal command. Alright, that's it for today. I hope you liked this video. If you did, please send me some kudos to the comment section. If you didn't, I will really appreciate any constructive feedback from you as well.